In this problem, we are asked to find the amplitude, the period, the phase shift, and sketch the graph to y equal to 5 sine of 3x minus pi over 2. We will recognize that this is in the general form of y equal to a sine of bx plus c. In our case, a is 5, b is 3, and c is a negative pi over 2. We are now ready to find the amplitude, which is that maximum output value. We will recognize that this is at the absolute value of a, in our case the absolute value of 5, which is 5, meaning our range of our function is between minus 5 and positive 5. In order to find the period, we could use the equation 2 pi over the absolute value of b. In this case, it would be 2 pi over 3. This means that our one cycle graph would go 2 pi over 3 units. We are now ready to look at the phase shift. Our phase shift is given by the formula, the opposite of c all over b, where c is equal to a negative pi over 2, so the opposite of c would be a pi over 2, divided by b, which is 3, which gives us a phase shift of pi over 6. We can now verify this by finding our one cycle interval, knowing that 3x minus pi over 2 needs to range between 2 pi and 0, adding pi over 2 to both sides. 2 pi plus pi over 2 is 5 pi over 2. Finally, dividing both sides of our problem by 3, I would get the one cycle interval of positive pi over 6 to a positive 5 pi over 6. We can verify this is indeed 2 pi over 3 units in length. We are now ready to use this information to sketch our graph. In order to sketch the graph, I took the interval between pi over 6 and 5 pi over 6. We are now ready to find those critical values for sine. We know at the start and stop of our cycle interval, sine takes on the value of 0. Therefore, at pi over 6 and 5 pi over 6, we have our x-intercepts. We could verify that by solving the sine of 3 times pi over 6 minus pi over 2 to see if we indeed get 0. 3 times pi over 6 is pi over 2. Pi over 2 minus pi over 2 is the sine of 0, and the sine of 0 gives us 0. We are now ready to take our interval and divide it into our 4 equal segments. We can do this by hand by recognizing that halfway between the interval would be 3 pi over 6, and then halfway between each of the other 2 intervals would be 2 pi over 6, which is pi over 3, and 4 pi over 6, which is 2 pi over 3, respectively. Another way we could verify this is we take our period of 2 pi over 3 and divide it by 4 equal parts. This would give us 2 pi over 12, which is indeed pi over 6 units in length. We know that halfway between our interval of pi over 6 and 5 pi over 6, sine again reaches an x-intercept. Therefore, 3 pi over 6 would also be our x-intercept. Halfway between pi over 6 and 3 pi over 6, it will hit its maximum value at 5, and halfway between 3 pi over 6 and 5 pi over 6, it will reach its minimum value of negative 5. We are now ready to sketch that sine function. We can see that it got stretched vertically, compressed horizontally, and finally it got moved by its phase shift of pi over 6 units.